Hello Deshni, just doing another video for you for the other question you sent through, and again this time I've written it down on a piece of paper just to make it easier for the maths method students who are watching this and any other viewer who's watching this to see what the question is and what we're actually trying to work out. So what do we have? We've got a particle is moving in a horizontal straight line. Position is measured from point O. The particle starts at a point 20 meters to the left of O. The position time graph for the motion of the particle is as shown. At which times is the particle at O? Alright, what do we have? So we've given a position and time graph. We know the position starts from -20, and we can see that it's moving towards the origin, and it hits the origin at 2 seconds, goes past the origin, stops, comes back, hits the origin again, and continues going forward, and then slows down, stops, and then returns back and goes towards the origin and goes past the origin. So for part A, which times is the particle at O? We can say that the particle is at O at the t-intercepts. Okay, and what's our t-intercepts? T equals 2, t equals 3, and t equals 8 seconds. Okay? These are the times that the object or the particle is at origin. It's cool. Alright, for part B. For which values of t is the particle moving to the right? Okay. Now to be able to visualize this, it'd be good to draw a horizontal line where the particle is actually moving. And so we've got O here, and if we have -20 here, that's where it starts. So our object is moving towards the origin. Okay, now we know that if 20 meters to the left, so in this direction it's left, and going in this direction it's going to be right. Okay, so looking at the graph, when we're going from negative to 20 to the origin, our graph is positive. So that tells us that every time the graph is positive, then we are moving in the right direction. Okay, so all we have to do here is work out what our intervals are for when the graph is positive. Okay, so we're starting from 0 and we're going all the way, we're past 2, and then halfway from 2 to 3, that's when the object stops being positive and becomes 0. So then our intervals are going to be from 0 all the way to 2.5. Okay, so that's our first interval from 0 to 2.5 where it's positive. Okay, and then the other part, so we put that in a curly bracket. Okay, and then we just put U as union, or it means or as well. So this interval or, so where else is our graph positive? So it's positive here, and then it gets negative here, and then it's 0 there, and then it starts becoming positive. So here our value is going to be 6. Okay, so when t is going to be larger than 6. Okay, so in these two intervals we're going to have a positive gradient, which means the particle is moving towards the right. Okay, and for part C, we've got for which values of t is the particle stationary. Okay, what does that mean? Well, if this is this is the position time, the gradient of this graph is going to tell us the velocity of this object, and whenever we're stationary, when stationary, then our velocity has to equal 0 because you're not moving. Alright, so if our velocity has to equal 0, that means then our gradient for this graph has to equal 0. Okay, so where in this graph is our gradient equals 0? So we're going to go this way here, and then we're going to stop here. So at 2.5, we're going to have our gradient equals 0, so therefore we're stationary at t equals 2.5. Also, we're going to be stationary at this point here, so at that point is t equals 6. So t equals 6 seconds. Alright, that's it. I hope this video helped. If any parts of it did not make any sense, just comment below and I'll comment back and try to explain it in a more clearer way. Otherwise, thanks for watching, and for any other maths methods students out there, if you want me to tutor you for maths methods, then you can go to my website mathshelp.com.au, where you can find my contact details. And if you found this video helpful, then don't forget to click on that share button. So take care, and I'll see you guys in the next video.